Okay, in this video, we're going to talk about the mathematical functions. We have, in our lives seen a lot of kind of functions. We've seen rational functions, greatest integer functions, modulus functions. We see graph of function. We see identity function. Now, what do we actually mean by this word function? What are these mathematical functions? Okay, so mathematical functions, can be defined in two manners. You can look at it as a set of, say, ordered pairs, okay? And also you can look at it as a correspondence between the elements of two sets, okay, A and B, okay? So it can be ordered pair set, okay? So in that sense, it's a relation. Essentially, function is a relation between the elements of the set A and elements of the set B. Okay, so it's a simple relation. So a relation essentially is a set of ordered pair, right? A set of ordered pair which are essentially subset. A relation is a subset of the Cartesian product of A and B. Okay, so let A and B be any two non-empty sets, okay, non-empty set, then a relation F from A to B, okay, from A to B, essentially that means that it is a subset of A cross B, is a function if it satisfies two properties. If it has to satisfy these following two properties in order to be a function, okay, in order to be a function, F, which is a subset of A cross B, has to satisfy two properties. Then it is called a function. So what are these two properties? Now, these two properties are essentially related to the elements of A and B. So first one says that for each and every element in the input set A, okay, so each and every element in the input set A, there exists B belonging to the set B. Now essentially there exist means that there should exist at least one, okay, there should exist at least one. So there exists B belonging to the set B such that the ordered pair A and B, okay, that is the relationship between A and B. Ordered pair belongs to F, that is A is related to B, okay, such that ordered pair A, B belongs to the relation F, okay. Number two point that it has to satisfy is that under the relation F, in case A is related to B, that is A, B, the ordered pair belongs to F, and A is also related to C under the function F, under the relation F, then that should imply that B is equal to C. Okay, at one point of time, A can't be related to both. So what we are trying to say is that unique image. A has to have a unique image under the function or relation F. A has to have a unique image under the relation F. Okay, so that's what we are trying to say. And so B, there is for, B is your image of A and A is called the pre-image of B under the relation or function F. Now, as a correspondence, so what would we mean by correspondence? That correspondence would mean that there is some sort of association between the elements of the two sets A and B. Okay, so you have two sets A and B. Let A and B be like, non-empty sets. Okay, so if A and B are non-empty sets, they have certain elements in between. So the function F, then a function F from set A to B, function F from set A to B is essentially nothing else. It's a formula, it's a rule, it's a method, it's an association, it's a correspondence. Written as F goes from A to B. F goes from A to B, okay, is a rule, a method, a correspondence which associates elements of the set A to the elements of the set B in a certain manner. It's a rule, it's a method, it's a correspondence between which associates the elements of the set A to the set B in a certain manner. Now, what is that certain manner? To elements of set B such that there are two things that should happen. Such that all elements of the set B are associated to the element of set B. All elements of set A should be related, should be associated with the elements with the element of B, with the elements in the set B. Now, what we mean to say is that there cannot be any free element in A. Okay, all elements of A should be exhausted. An element of set A. Number two is that an element of set A is associated to a unique element in the set B. An element of set A is associated to a unique. Now, this is very similar to the previous definition as well. There we were looking at a set which is a relation. Okay, now we are looking at a correspondence. So every element of A has to have a unique image, and that's what it means, that the association, any element of A which is associated, it should be associated with a unique element in the set B. Okay, so that's very important, uniqueness of this association, which is same as the previous one, where we were saying that it has to be unique, the image has to be unique. So it's the same thing, the image has to be unique. Okay, so you have elements in A, you have elements in B, so there is an association from an element of A to B, association from element A to B, just like this. So it's essentially like a mapping. It's like a mapping, right? So it is like a mapping, or we can, we can say that F goes from A to B. F goes from A to B. It's a mapping. Mapping of one element to another element in the other set. So it's a mapping written as either F goes from A to B. Written as either F goes from A to B or F A to B is a mapping under F. It's a mapping under F. So either ways you can write it. You can see it here, how we write it. We write it as F goes from A to B like this, and so this is a functional notation. This is a functional notation, or else a mapping notation, generally written as F is a function from A to B, or F maps from A to B. This is essentially a formula or a relation, a mapping. So that's what is a function from A to B.